You ever wonder what's really going on inside the mind of an AI when it writes a poem or recognizes your face? It honestly feels like magic. But what if I told you it's a lot more like school? Well, today, we're taking a field trip inside a digital classroom to see exactly how these incredible machines are taught.
So here's our plan. First, we're going to figure out what learning even means for a computer. Then we'll peek inside its digital brain. After that, we'll look at its study method, explore the two main kinds of classes it can take, and we'll finish up with its final report card, asking the big question: is it truly smart or just an amazing mimic?
All right, class is officially in session. Before we get into the how, we really need to agree on the what. What does it even mean for a machine to learn anything?
I mean, this is the big question, right? For decades, we had to hard code every single rule for a computer. If this happens, then do that. But AI is totally different. How in the world does it manage to do things it was never explicitly programmed to do?
Okay, so at a super high level, artificial intelligence is really just about getting computers to do things that usually need a human brain. We're talking about understanding what we say, spotting a friend in a photo, or even making a really complex decision. And the how behind almost all of today's AI is this idea: machine learning. This was the game changer. We stopped feeding machines a giant list of rules and instead started feeding them data, just massive, enormous amounts of data, and letting them figure out the patterns all by themselves.
Okay, so if the AI is learning from data, where is all this learning actually taking place? Let's take a look inside the AI's so-called brain.
This whole structure is called an artificial neural network. And yeah, it's a computational model that's loosely inspired by the billions of interconnected neurons we have in our own heads. This is the engine room where all the heavy lifting happens.
It kind of works like an assembly line. Information, let's say the pixels from an image, goes into the first stop, the input layer. Then it travels through one or more hidden layers. This is where all the complicated processing goes down. And finally, it gets to the output layer, which spits out a final conclusion. Something like, yep, that's a cat.
So how does the network actually think? Well, every single one of those connections has a weight. The best way to picture it is like a tiny digital volume knob. The AI's entire job during its training is to figure out how to tune millions, sometimes billions of these little knobs. These weights are what determine how important any one piece of information is as it zips through the network.
So we've got the brain, but how does it actually study? Well, that brings us to the absolute core of how an AI gets smarter, the training loop.
This is basically the AI's version of cramming with flashcards. First, it sees an example, like a picture of a dog. Second, it takes a guess, a prediction, dog. Third, it checks the answer key. Was it right? The gap between its guess and the correct answer is what we call the error. And fourth, and this is the most important part, it uses that error to go back and slightly tweak all those little weight knobs so it can make a better guess the next time around.
And here's the thing, it doesn't do this just once. It repeats this loop millions or, get this, even billions of times. And with every single cycle, it gets just a tiny, tiny fraction better. This isn't some elegant human-like insight. It's learning through pure, mind-boggling, brute force repetition. But wait, how does it know which way to turn those millions of knobs? Well, it uses this really clever mathematical trick called gradient descent. Imagine you're a hiker on a super foggy mountain, and you want to get to the lowest point in the valley. You can't see the bottom, but you can feel which way is downhill from where you are. So you take a step in that direction. That's exactly what gradient descent does. For every single knob, it finds the downhill direction that will reduce its error the most, and it takes one small step. Now, not all AI training is exactly the same. Just like in human schools, there are different teaching styles. Let's look at the two main classes an AI can take.
So, the most common method, over on the left, is supervised learning. This is like studying with flashcards that have the answers on the back. Every single piece of data is labeled. The AI sees a picture of a cat, and it's told explicitly, this is a cat. Now, over on the right, you have unsupervised learning. This is more like being dropped into a massive library and told, go find some interesting connections. The AI gets a mountain of unlabeled data and just has to find the patterns all by itself, like grouping similar customers together without ever being told what the group should be.
Those AI chatbots we all use are the perfect example of supervised learning, just on a ridiculous scale. They were trained on pretty much the entire internet. Their job was simple, but enormous. Given a sentence like, the cat sat on the, their only goal was to predict the next word, Matt.
By doing that simple task billions and billions of times, they didn't just learn language. They learned grammar, context, and even facts about our world, all from the hidden patterns in the text.
So after all this training, after all this school, it's time for the final report card. What has the AI actually learned? Is it truly intelligent? Or is it just a really, really good student at memorizing?
When you strip away all the hype, here's the fundamental truth. An AI doesn't understand concepts. It recognizes patterns. It doesn't know what a cat is with all the fuzzy, purring, real-world context a human has. It only knows that this specific statistical arrangement of pixels has an extremely high probability of being associated with the label cat.
And that leads to a really crucial distinction. Human intelligence is about conscious reasoning, self-awareness, and true understanding. Current AI systems are built on something else entirely. It's all about pattern recognition, probability calculations, and processing data at a scale that we can't even really comprehend. It's not better or worse, it's just a completely different thing.
This also means it has some serious limitations. It's only ever as good as the data it was trained on. So if that data is biased, you guessed it, the AI will be biased. It has no real-world common sense. And maybe the most dangerous thing is that it can generate answers that sound totally confident but are just flat-out wrong, something people are now calling hallucinations.
Which leaves us with this final, massive question. We've built something that can write and create art and solve complex problems just by mastering patterns and data. Is this the end of the road, an incredibly sophisticated mimic, or are we watching the very first baby steps of a totally new kind of intelligence taking shape? The answer isn't clear at all, but understanding how it learns is the first real step to figuring it out.